All right, and welcome to the lesson 5.4 geometry notes on use congruent triangles. All right, so we're going to keep building on a lot of that proof stuff we've been using and proving triangles congruent. We'll add just one extra little piece here that after once we know we have some congruent triangles, we can use them to maybe make other statements about parts of those triangles. So we'll also look at towards the second half of the lesson some properties of isosceles and equilateral triangles. So let's do it. Let's get into it. Let's finish it up. Here's the one really note on the congruent triangles portion of the lesson is a little bit of just let's kind of focus a little bit here one at a time. So that once we know, hey, congruent figures, whether that's triangles, quadrilaterals, anything else, if we have congruent figures, that definition said that they have corresponding parts. Remember, parts we defined as sides and angles. So corresponding sides and corresponding angles that have to be congruent, right? That was part of that definition of congruent figures. That they basically had matching parts that all had to be congruent, angles and sides. So really, we're going to kind of use that definition and say that, hey, let's just pretend we have a triangle right here and a triangle right here. And I go through some a proof and establish that, hey, I've got a pair of sides that are congruent, I've got a pair of angles that are congruent, and then however it works out, however we're getting this information, that I know that this pair of angles are congruent. So then I say, hey, you know what? Based on the angle side congruent shortcut, this triangle on the left is identical, has to be congruent to the triangle on the right. Right, so we'll go through and we'll do that proof. We've been doing those in previous lessons. But after I establish that, hey, for sure, this triangle is identical to this one, we could go on further and say, well, if the triangles are identical, don't we also know that this side must be congruent to this side? And if we wanted to say, oh yeah, that's right, this side has to be congruent to this side too. And oh yeah, that third angle, we could have did this earlier, but that third angle has to be congruent to that one. So there's some different things that we might say after we establish triangle congruence. So that's kind of how the process is going to work. Our new reason, our new explanation, a property really, it's really just kind of a different way of stating that this definition of congruent figures. So you can kind of see the little bit more formal here in the proof that we were given all this information. We said, hey, you know what? These triangles, triangle RST has got to be congruent to triangle UVW by the SAS congruence shortcut. So then after that, we could say, oh yeah, you know what? Angle T has got to be congruent to angle W because corresponding parts of congruent triangles are congruent. Here's kind of the big, at least the abbreviation. That's a lot to write. We don't always want to write that. So here's what we're going to use. The C stands for corresponding parts of congruent triangles are congruent. Okay, so that's kind of the new piece to the puzzle here. It's not a whole lot of extension beyond what we've been doing in previous lessons. It's using those congruent triangles to make a statement, a valid statement about another part of those triangles. Okay, so enough build up here. Let's do a couple. I've got two of them set up for us to go through. So the first thing I'm going to notice is that the proof statements are different, right? So the previous proofs we've been doing for this chapter have all said prove triangles congruent, prove triangles congruent. What we just talked about, we're still going to do that. We're still going to show this triangle is congruent to this triangle. We're just going to follow up afterwards and say, oh yeah, hey, this has got to be congruent to this because of that corresponding parts of congruent triangles are congruent. So it's almost like a little bit of a stock finish as far as how we're going to finish this, okay? So let's jump in here. Let's get it going. What's been our process here? It's been use three blanks. We're looking for sides and angles that we can justify and say are congruent. So I've got a piece of given information here that says segment GK bisects angle FGH. And that same segment also bisects angle FKH. Okay, that's given to us. So nothing is, as far as I haven't said anything's congruent to anything, so I don't have anything in my blanks yet. Let's go. Let's take a look. Let's address this given information. Whoops, I forgot to write where did that come from? That was given to us. All right, now let's address the given information. We got to be careful here. something's getting bisected. We've seen in other examples that we can bisect segments, we can bisect angles. All right. What's getting bisected? Remember, cut in half. So angle FGH. Where is FGH? If I highlight it here, angle FGH is this big angle on the entire figure. So if I cut that big angle in half, we're going to end up with two smaller angles right there and there. Okay, that's what that first statement means to me, that when I say GK is bisecting FGH, I've kind of illustrated here in pink on the picture, that's what has to be true. So we should say angle FGK, I'm talking about that top, this angle right here, FGK has to be congruent to angle HGK. Why? Because of that definition of bisect. Definition of bisect. Remember, you could be super specific, and it would probably be better to say the definition of an angle bisector. But for right now, we can just say, hey, that's what it means. We're cutting something in half. It's just the something we're cutting in half happens to be an angle. Okay. Let's keep building on that same piece of given. That's just half of it, right? If we keep reading, it says that GK also bisects. Let's just kind of erase this for a second. GK bisects angle FKH. So I got to look at the picture and see, where is angle FKH? We've kind of got that exact same situation that we just talked about going on the other side, right? So that big, what we're seeing as kind of this blue angle is, hey, that's getting cut in half. We're going to cut an angle in half, so I'm going to end up with two smaller but equal congruent angles. Okay, so you know what I'm going to do? I'm going to on the same line on step 2 here, because it's the same reason, kind of same piece of given. We can just say angle. How would I name these two smaller angles right here? Angle FKG. So angle FKG has to be congruent to angle HKG. And you got to be, look at those last two statements on the left side here. They're really similar, right? FKG or FGK, FKG. We're using the same letters, same ways to name the angles, except obviously it's important where that vertex goes. Here we're talking about the G's in the middle, so that we're talking about these two angles over here. The K's in the middle here, so we're talking about those two angles. All right, so we've kind of exhausted our given information. That got us the first angle. It's color-coded. Was these two over here. And then we took it a step further. The other piece of given information got us this other pair right here and here. All right, so our given information is used up. We're kind of in a spot where we're not quite ready to go because we've only got two of our blanks filled. Where's my third piece going to come from? Hopefully we're all shouting at our screens saying, hey, it's that side that they're sharing, right? We've seen this in a lot of our proofs. So I know our third thing that we need to say here is that segment KG is congruent to segment KG because of that reflexive property of congruence. Okay, so that's one that we can always just kind of add as long as I see that in the picture. I'm looking at the top triangle, the bottom triangle. They each are using this segment KG as one of their sides, so they're kind of sharing that side. So that's a really great way to add another an angle or a side, another part to the mix here. And there we go. I've got three separate statements. This is congruent to this. This is congruent to this. This is congruent to this. So I'm confident to say, hey, let's check those all off and say we're good to go. Here's kind of the newer part. We haven't done this yet. So now the next thing I need to say, I actually have to state the two triangles are congruent. Okay, for the most part, the proofs up until now, that's been the proof statement. So it's on us now to accurately say, hey, this triangle is congruent to this triangle. So I'm going to start with the top triangle. I'm just going to call it triangle, And I'm going to start right here and go triangle KFG. Okay, so triangle KFG. I'm making that decision. I'm just kind of looking at it and seeing, hey, you know what, that top triangle I'm going to call triangle KFG. All right. Has to be congruent to. Now I need to name this bottom triangle so that everything lines up. How did I travel on this first one? I started at the single arc. I traveled to the unmarked angle, right? So I traveled up here to the unmarked, and then I finished at the double angle. I got to follow that same path on this bottom one and say single arc, unmarked to double arc. It's an easy way just to kind of follow your markings and just say, hey, now I got to go this way, K to H to G. So triangle KFG is congruent to triangle KHG. Because remember, we want this statement that we just made, all the corresponding parts to line up, right? Like, so segment KF, the first two letters listed, should line up with its matching its partner, KH, and I think they do. KF corresponds with KH, so we got to say it in that way. All right. And then the other part of this is, okay, well, how did I know those triangles were congruent? Which shortcut did I use? So I'm looking back here. I'm looking at my picture, mainly looking at the pictures. Be careful that we don't take this as, oh, it's got to be AAS. That's just the order that we found them. Let's look at this top triangle just kind of on its own. I see an angle. I see a side. And I see an angle. The side is sandwiched in between the two known congruent angles. So this is actually not AAS. It's actually an example of angle, side, angle. Okay, so I'm going to say that, hey, triangle's got to be congruent by angle, side, angle congruence. Okay, so at this point, we're sitting here. That's how a proof has gone in all the previous lessons. I think here we're just following up now and saying, all right, we're taking a deep breath and saying, hey, I think we did it. I've established these two triangles are congruent. I'm just going to follow up with, hey, you know what? This was asking me to prove that segment FK is congruent to segment HK, which I think we can say at this point. Why? Because, let's see, where are they? FK, where is FK? Right here. And segment HK, they're corresponding parts in triangles that we've just shown to be congruent. So there's that abbreviation we're going to use. Corresponding parts of congruent triangles are congruent. All right. So like I said, that's kind of a stock finish on one like that. The work is mainly us proving the triangle's congruent, stating they're congruent using one of our 5 shortcuts, and then, like I said, kind of finishing up with that CPCTC. All right. One thing to note, I didn't mention it, but I know it's a common mistake that people make right from the very beginning, actually. Right. This is what we were trying to prove. So at no point are we ever okay to say, oh, let's use that. Let's use FK and HK as congruent. We're not told that they are. We're actually trying to show that they are. So that's always going to be the last thing that we finish with. Okay. For number, let's just jump into 2 right here and take a look. For example 2, here we go. Same approach, same same process as we've done. I think we can go a little quicker here. We're seeing some different stuff, but it's not that we've never seen these before. So let's jump in. Let's do it. Given point P is the midpoint of segment MS. All right, that's given to us. That's not a statement of congruence, so I'm not going to put a little S or a little A in my blanks yet, but it's going to help us get something later down the road. And then we've got this separate piece, or 2 separate pieces, that segment MN is perpendicular to segment MS, and also segment RS is perpendicular, I think that's what I just said, to segment MS. Okay, so again, it's not a statement of congruence. We got a little bit of work ahead of us here as far as we got to come up with these 3 things. So let's take a look. Here we go. Let's start with this first sentence, that P is the midpoint of MS. So I look at the picture and I see, where is MS? It's right here. Here's MS. P is the point right in the middle of between M and S. So therefore, MP would have to be congruent to PS. All right, so I think we can state that and justify it. Segment MP has to be congruent to segment PS. All right. How do I know that's true? What am I going to justify that with? Well, I saw this word right here and I knew what that meant. So I used the definition of the word midpoint. The fact that I marked the segments, I've justified it, I stated it. All right, cool. We can use this. We can use the S. We can get a little S going on there. We've got a segment marked as congruent. Great. Let's keep going with the given information. All right. So I think we can kind of we can work with these two pieces together here. When I see segment MN, when I see this statement MN, so where's MN? It's right here. MN is perpendicular to MS. That tells me in my head that, you know what, I should add a little right angle right there because I know that perpendicular means right angles. And very similarly, like identical, RS being perpendicular to MS also tells me, hey, there should be a little right angle symbol right there. So this is that one that's a little bit weird that I actually have to state, what did I just add to those pictures? Angle M and angle N are right angles. Okay, I'm not saying they're congruent yet. I'm just establishing the fact that, hey, you know what? I saw this symbol for perpendicular, and that was the trigger for me to say, yeah, that's got to be a right angle, and that's got to be a right angle. So I'm going to use, to justify that, the definition of perpendicular, right? We know perpendicular means to intersect at a right angle. Now, afterwards, after I've established, hey, those are right angles, we can definitely say, and we should say, that angle M is congruent to angle S because of that right angle congruence theorem. Remember, that was a theorem that says every right angle, that as long as you know it's a right angle, has to be congruent because of that reason, the right angle congruence theorem. So that's good for us. Awesome. We've got an angle. We've used that information, and we're kind of in that same position as we were in the last proof where we've kind of exhausted all of the given information. So our only option at this point is to look at the picture and see, is there anything else that I can just add and still obviously be able to justify. So I look at this figure and see, you know, this is one we've seen quite a bit as far as, I call it the hourglass or a bow tie, that I've got a pair of vertical angles right there and there that have to be congruent. I have to use the three letters, and I know we talked about this in the previous lesson, but I can't just say angle P is congruent to angle P. I'm talking about two different angles. I need to state, hey, angle MPN, so let's say it that way, angle MPN has to be congruent to angle RPS, let's say it like that, RPS, by that vertical angle theorem. Okay, and again, just to clarify, that's another angle. Let's just finish this up. When do I got to use three letters? Why was it okay to use two letters here? I know we've talked about it. That's the only angle M on the page. That's the only angle S on the page, right? There's multiple. There's actually 1, 2, 3, 4 different angle P's, if you wanted to call those angle P's, where the vertex is in the middle there, or where P is the vertex. So that's why we have to clarify. M is the vertex on one angle right there. Okay, so that's why you got to use three letters. Okay, again, there's a little bit of like a sigh of relief here. That's the work on this one. That's 5 steps just to show. I'm just going to use numbers for right now, that triangle 1 and triangle 2 are the same. As long as I can justify it, right? So I'm going to have to come up with, maybe we can do that right now. Which shortcut? Let me take some of this stuff off there. There's a little bit, I don't know where my eraser goes. See, can I clear this too? Maybe take some of those dots off of there. I'll re-put those markings back on, take the 1 out. All right, so what did we have here originally? We had this congruent, whatever. That congruent to that. So which of my 5 shortcuts are we looking at here? I think, unfortunately, it's the same look. I like to try to vary the looks. I see an angle. I see an angle. I see a side, and I see another angle. So 2 angles and a side, right? It's not SAA. It's actually angle, side, angle again. So that's what I was saying. I wish I had a different look for us, but it is what it is. It's angle, side, angle. So I'm going to slide up here and state that. I actually have to come up with the triangles first, so I'm going to probably have to scroll a little bit because I lost sight of it. Triangle, let's name the top one however we want to name it. Triangle MPN, I'll go with. Triangle MPN has to be congruent to triangle. Now I got to be careful here. I went right angle, vertical angle, unmarked. So I need down here, I need to go right angle, vertical angle, unmarked. So SPR is how this one has to be named. Triangle SPR. How do I know those triangles are congruent? I believe we said the angle, side, angle, congruent shortcut. There's even a deeper side because now we're saying, hey, you know what? We just established triangles are identical. Let's finish this up and say, I think I can maybe see this here. Any matching parts have to also be congruent. So for us, we're specifically talking about, well, let's find a new color. What do we have to use here? Red. That angle N has got to be congruent to angle R because they're corresponding parts of congruent triangles. And we know they have to be congruent. So remember, corresponding parts of congruent triangles have to be congruent. Wow, 7 steps. That's legit. So hopefully we're kind of getting along with those and we're getting better. The nice part is we're really just extending the previous lesson by 1 extra step. Okay, so either if you struggled with it, we're getting some of that reinforcement, some extra practice with it. The flip would be if you did really well with the previous lesson, this should be going really smooth. Okay, so that's two looks. Unfortunately, they were both ended up being ASA as far as this part, but we saw some different things here. Vertical angle theorem. We saw reflexive, right angle. So I think it was a pretty good look, pretty good variety. All right. So that's the first part of the lesson as far as using congruent triangles to prove other angles or other segments, sides are congruent. The last part is a little bit shorter. It's properties of isosceles and equilateral triangles. So let's add the notes portion to our notebooks. So we've got, let's just look at them one at a time here. Basically what this means is, all right, so your heading should be the base angles theorem. All right, so base angles theorem. We did it with pictures in class, but it basically says if you got 2 sides of a triangle congruent, which makes this what type of triangle? When I have 2 sides congruent, this has to be an isosceles triangle, so that's why we're talking about isosceles triangles. If I know that this triangle right here is an isosceles, which I know it's congruent, then I also know that what we call the base angles, which are down here, which you're seeing this, are opposite those congruent sides. So if I kind of followed this and walked down here, I'd know that this angle and I also know that this angle right here have to be congruent. Okay, so we kind of wrote it as if you knew you had an isosceles triangle, then that same isosceles triangle would also have to have congruent angles. All right, we did it more with a picture. That's a two-way street, so it works the other way as well. That if I happen to have a triangle right now, I don't know it's isosceles. I just see the picture. So this is how we did in class. If I have a triangle that is known to have a pair of congruent angles in it, that triangle would have to be isosceles because the sides opposite them would be congruent. So that's all we have to know, that we have a pair of angles that are identical, congruent. That same triangle would have to be isosceles. Okay, so a little bit of a two-way street there. Kind of if you know one, you know the other. If I know sides are congruent, I know opposite base angles are congruent. If I know base angles are congruent, I know opposite sides have to be congruent. So that's the first part. That's the property of isosceles triangles that we need to know. Kind of what goes right along with this, it's a corollary, and I know we've seen that in other sections, but it's just basically just a real quick follow-up to that. And it involves equilateral triangles, and it's just a straight up statement. So if you want to do it kind of the same way with the pictures, if you have a triangle that's known to be equilateral, that same triangle that's equilateral has to also be at this exact same time equiangular. Okay, and then the converse works just the other way. If I've got a triangle and all I know about it is that it's equiangular, you could say, well, I actually know more than that, because if it's equiangular, that triangle has to also be equilateral. So that's kind of the takeaway, that every equilateral triangle is also equiangular, or saying that vice versa. Equiangular has to be equilateral. All right, so that's the property of an equilateral triangle. Great. So these, we're not going to use these theorems, so don't feel like we're going to use these in proofs or anything like that. It's mainly just to kind of find unknown missing side lengths, missing angle measures, and angles. So here's just a quick look. There's lots of different things we could look at. We'll maybe do a follow-up one, but it's just basically asking me to find the value of x and y in the picture. Now, it's a fairly complicated picture, I think. What's trying to be illustrated here is there's obviously multiple triangles that are overlapping. I've got a triangle here that's marked as equiangular. All right, I think this corner down here kind of can give us trouble. There's like double sets of markings. So if I highlight them in color, I think we'll be all right. So I've got this big triangle. I know it's equiangular. If I want to just right away and say, you know what, if that's equiangular, doesn't this whole thing have to be equilateral? And say, yeah, okay, that's exactly what's going on. So I think X is going to be no problem to find based on that information. And then I look at, there's this other somewhat larger triangle here that's kind of laying on its side, or whatever. Hopefully you know what I mean there. That it's kind of laying down. But based on these markings, I got a pair of angles that are congruent. So the sides that are opposite them, this one and this one, have to also be the same. And since I already marked this whole side with a single tick mark, I should probably just mark this side with a single tick mark. So in the end, we end up knowing that this, and this all are identical. So x equals 2y equals 8. I think we have to start here. Well, not necessarily. You could say that 2y has to equal 8 because it's going to be true, but let's just find our x. Our x has to be 8, right? X equals 8. And just because it's congruent to this one here. And then if I wanted to find y, I know my 2y has to also be 8. We kind of just verbally said it, so y would have to equal 4. So not bad. That's an example of maybe one on the maybe easier side. I don't want to necessarily call it an easy problem, but we have to see some of those properties there. I'm going to just kind of make one up here for us, just so we can kind of see just a different look slightly. That say I have a triangle. All I know is this, and let's say we know that this angle right here is 50 degrees. And I say, find that measure right there. So this is 50 degrees. This is x degrees. And I say, find x. What's the value of x? So I think on initial, like on just on the surface, it's like, well, do we have enough information here? And I'd say, yeah, right? I wouldn't give you the problem probably if there wasn't enough information. But I look at the triangle, I see its isosceles, and I say, oh, hey, that's right. This angle here has to be the same as this angle right here. This also has to be 50. And in a triangle, going back to our first lesson, we know that all three of these angles have to add up to 180. So 50 plus 50, oh, that's nice, is 100, meaning x would have to have a value of 80. Now, it's not the most accurate picture, but I think it's good enough. X would have to equal 80. Why? Because all three angles have to add up to 180. One other just quick, a very similar one here that kind of follows this, just changing the information maybe. So we could potentially see something like, again, same markings maybe, and maybe all we know is this is, I'm trying to make it kind of accurate. Hey, that's 70 degrees. Find the other two angles. So then now you look at, well, wait a minute, hold on. That's not enough information. And again, I'm being a little silly because I wouldn't have asked you it if we weren't able to do it. All three angles, this one, and this one, have to add up to 180. You say, well, these are both unknown, but we also know that this has to be congruent to this. So that's where if I wanted to call this x and I wanted to call this the same thing, I could say x plus 70 has to equal 180. Whoops, 2x. Well, let's go ahead. Fine, I subtracted it from both sides. X would have to equal 55. So some different looks for us there. Those last two, if you couldn't tell, I kind of just made up a little bit, but just trying to get us to see it a little bit differently. Some different ways we might see some of these problems. Okay. But I think other than that, I think we hit, we'd use these properties to find some unknown side lengths or angles. So I think we should be good there. So I think that's it. Not a terrible lesson as far as lengthwise, and hopefully a concept-wise either, as far as we're just building a lot on stuff that we've done in earlier lessons. So that's all I got for us. Let's call it a day here on this 5.4 notes, and I will see you in future lessons.